In the last lesson, we looked at how data analysis items called measures of variability or measures of central tendency can help us to pick one number that will represent a data set. And we used, as an example, the test or the quiz results from one of my classes to kind of ask the question, how did my class do? If I was to represent them, how would I represent them with one number for their score out of 51? How would are there any students I should work with, things like that. So how do I use measures of central tendency to help me make decisions? In this lesson, we're going to be looking at what are called measures of variability, things like range, quartiles, IQR, which stands for interquartile range. Okay, we'll get into that in a minute. Those are things you've done before, but we're going to really hone in on how do we compare data sets. We'll also get into how to make box and whisker plots. So just to review, we're, the three vocab terms here are first quartile, third quartile, and IQR. You'll remember from the last lesson that median is the middle value. In an ordered series or ordered data set. Okay. The first quartile then would be the median of the first half of the data. So here in Western PA, whether or not you follow it, you are aware that there's a sport called football. And that a lot of people do follow it. And in a football game, if you think of halftime, there's actually no action going on at halftime. Halftime would be like the median, right? Halftime would be like the median. That's the midway point of the game. The first quartile would be like the middle of the first half. So after the first quarter, right? Think of the word quartile. It sounds like quarter. Okay, so the advantage here is that instead of breaking the data into halves, we're breaking it into fourths. Because imagine I had a data set where like you had a bunch of numbers like this, and then you had like this. Well, the median might be here, right? But if I only look at halves, well, this half is really tightly bunched, this half is really spread out. So by breaking it into quarters, I get a better view of what the data actually look like. Third quartile. Third quartile then logically is the median of the second half. So if we're splitting it into fourths, then each quartile is 25% of the data. IQR stands for interquartile range. Now the range between two things is the difference between those numbers, right? So like the range in temperatures, let's say that this morning, the check temperature is 32. Let's say it goes up to 50 today. Well, the range in temperatures then is 18 degrees, 50 minus 32. The interquartile range is inside the quartiles. What's the range? So in other words, from the third quartile minus the first quartile. So how far apart are those values? That's the IQR. Now, the advantage of that is, let's say you've got an outlier, right? Well, an outlier, let's say if my values are like 1, 2, 3, let's just make a quick list here. Let's say my data set is 1, 2, 3, 4, 5, 6, 738. Well, the median would be 4, right? I'm sorry. The median would be, 4, right? Because then I'd have 3 numbers on this side and 3 numbers on this side. Okay. My first quartile, the middle of these 3 numbers is 2. That's my first quartile. My third quartile is 6. Now, the range of this data set would be 737. You might look at that and say, oh my word, this data is so spread out. But if you look at the data set, it's really not that spread out. What's happening is you got this bonkers outlier, right? So what the IQR does is instead of factoring in this quartile, it's going to be 6 minus 2, that's 4, okay? So the interquartile range is only 4. The overall range is 737. Well, that tells me right away, oh, I got this crazy outlier. Here's why this is valuable. If I go from the first quarter to the third quarter, isn't that half of the game? Okay, you have after the first quarter break comes the second quarter and the third. That's half of the game, right? So the IQR is 50% of the values. And it's not just any 50%, it is the middle 50. The middle 50, the middle half of the data. Since it's the middle half, it is unaffected by outliers. So it gives you a more honest evaluation of the spread because you're looking at it from that perspective, right? And then it might help you tell whether there's any outliers messing with your data set, okay? So let's put this into action. What I have here is I have this year's data from the Chapter 6 quiz, and I have last year's data from the same period of the day. So think about how I'm trying to eliminate bias here. My question I'm doing is how did I do this year compared to last year, right? How did I do with my teaching this year compared to last year? How spread out were the data, right? So I'm going to take a sample again. For my sample, I'm going to do, let me think here. I'm going to take every fifth number. So that is a systematic, let me do every fourth just so I get a little bit more varied data. I'm going to do every fourth number. So again, I'm not doing a census, I'm doing a sample here, right? And I'm doing a systematic randomized selection, okay? That'll help me avoid any bias, right? So here we go. I'm going to mark off every fourth. So this 1, 2, 3, 1, 2, 3. This one, 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 1, 2, 3. I don't get another one. There we go. So for this data set, I got 51, 49, 48, 50 and a half, 48 and a half, 49, that's it. Okay, I got 1, 2, 3, 4, 5, 6 values. Now the other data set, every fourth, here we go. 1, 2, 3, this one. 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 Okay, here we go. Let's see how many I get here. 44 and a half. 48, 51, 50, 42 and a half, 50, that's it. Oh, look at that, I got the same number. Okay, now if I'm going to do these, I need to do them in order. Okay, so let's go, my lowest here is 48, 48 and a half. I'm going to try to get them on one line. 49, 49. Okay, so I got this one, this one, this one, this one. 50 and a half and 51. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're good. Okay, this one, here we go. 42 and a half, 44.5. 48, 50, 50, 51. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're good. Okay. Now, when you are breaking this down, you'll need the minimum and maximum because that's how we would calculate range, right? So those values kind of matter for identifying the spread in the data. So for 2025, my minimum is 48. My maximum is 51. That's not that much spread at all. A little bit bigger spread in 2024, according to my sample. Next, if you're going to divide something into quarters, the first cut you make is in the middle. You cut it in half, and then you cut each half in half. So the first thing I need to do is find the middle of these 6 numbers, right? Now, if there are 6 numbers, half of 6 is 3. So I'm going to cut this in half right here. 3 on either side, right? See how there's 3 on this side and 3 on this side. Now notice 49, this 49 right here, that's happening in the second half. This 49 is happening in the first half. It's not part of the median. So that is included in the first half of the data set. That's key. Okay, the median is this little 49 here in the middle. That's the median. Now, the first quartile then is the middle between these values. So if there's 3 numbers, the middle of them is 48.5. Okay. I'll put that in there. And then the middle of this, 50.5. So the interquartile range is from here to here, right? That is 2 points apart. Remember, these are points on the test. So the interquartile range is 2. The range is going to be, so 51 minus 48 is 3. So the middle half of the data is only 2 apart. The range is 3 apart. So not that, it should be pretty evenly spaced. We'll get a better idea when we visualize it with a box and whisker plot. Here we go. Now the 2024 data set. 6 values. There's this. And there's this. The middle is here. So I have 3 numbers in the first half, 3 numbers in the second half. 48 happens in the first half, 50 happens in the second half. In between 48 and 50. There's 2 ways you can do that. You can actually think about what the middle would be. You could take the average. 48 plus 50 is 98 divided by 2. Or you can just understand that halfway between 48 and 50 is 49. Oh, look at that. They both have the same median. But will that mean they're both spread the same apart? Well, no, because look. Here, from the median to the minimum is only a difference of 1. Here, much bigger difference. That's a difference of 6.5 points. Okay. First quartile. The middle of these 3 values, 44.5. Middle of these 3 values, 50. So the first quartile is 44.5, and this is 50. So the IQR is from here to here. That's 5.5. Much bigger spread for that middle half. The range, by the way, from 42.5 to 51 is 8.5. So a lot bigger spread last year than this year. A lot more consistency according to my sample. And not only that, well, when we look at the box and whisker plot, we'll say, okay, consistency could be good, but what if it's consistently bad? So what a box and whisker plot does is it takes 5 key points here. The key points, you do need to mark this, are the minimum, the maximum, and the 3 quartiles. Another name for the median is the second quartile. It's going to put them on a number line. Now, our number line, we're going to do both of these data sets. It's going to be a stacked box and whisker plot. So we need to go from 42.5 to 51. So to simplify things, I'll just go from 42 to 51. So if you go to page 2, I've got a space here for that. So I'm going to start with 42 right here. Okay, and we'll go 43, 44, 45, 46, 47, 48, 49, 50, 51. Just number it up real quick. And then I'm going to use different numbers for the different years for 2025, or different colors. 2025, I'll use green. 5 key points for green. So we're going from 48 to 51. And I'm going to try to hover this in line with the 2025 like that, okay? So 48 would be about right there. Doesn't have to be perfect. We do want to try to get it close. And 51 is the high. Okay? Quartiles then. 48.5 and 50.5. Okay, 50.5 would be like here. 48.5 would be here. And then the median is 49 for both of them. That's convenient. 49. Okay, so those are my 5 key points. This one looks like garbage. Hold on. Okay. Those are my 5 key points. For a box and whisker plot, the whiskers show the outliers. Kind of like the whiskers on the cat, their purpose is to feel and to sense things, so they go out away from the face. So the whiskers go out to any outer points, right? And notice they're not very far away, so probably no outliers on this one. The box goes around that IQR, that middle 50%. So here we go. Notice how the box gets the dots go in the middle of the box. And I put a line down through the median to show that there's the halfway point. Now think about what this means. 25% of the numbers are from 48 to 48.5. 25% of the numbers I selected. 25% of the numbers I selected are from 48 to 48.5 to 49. 25% of the numbers I selected are from here to here. Now, that looks like there should be more numbers, but remember, the spread, how far apart these parts of the box and whisker plot, that is not about how many numbers there are, that's how spread apart those numbers are. So if we go back, this is the median and this is the third quartile. Look at the difference between the median and third quartile. Let me get up here, here we go. The median and third quartile are 1.5 apart, whereas these are only half a point apart, right? So there is a bigger spread from here to here, okay? And then just to polish off the conversation, this part here, 25% of the numbers are here as well. So the greatest spread for this year happened right here in the third quarter, or the third quarter, okay? So this would be like the first quarter, the second quarter, the third quarter, the fourth quarter, okay? And remember, this doesn't mean, just like in the quarters of a football game, the time is what's equal, not the number of points scored, right? So here, the spread would represent like how much more ahead one team is than the other. Still 15 minutes per quarter in a football game, right? But that spread, the way the points divvy out within that 15 minutes might be different. Okay, 2024, here we go. We're going from 42.5. This one's going to look drastically different. 42.5 to 51. So here's 42.5, right there-ish, to 51. Big difference there. Then we're going 44.5, 49. And then 50.5. Now, big spread. There's that whisker, and the box is here. There's the box. Clearly, the second quarter is a big spread. Okay. Do I have any outliers? In this data set, I kind of don't feel like I do, because this last 25% of the data, this is a quarter of the kids who I selected. Now that last 25% goes from 42.5 to 45.5. That's a difference of 2 points. This is the first half of the data here, right? From here to here. Half of the scores I selected are from 42.5 to 49. That's a pretty big spread. So if I was going to work with some kids, maybe I would work with this quarter of the students. Because from here to here, that's 44.5 to 49. Maybe I would make it optional for these kids if they wanted to participate in an extra review. You don't quite feel like you have it. You want to get ready for that unit test or whatever. These kids, I might make it required, right? So that, I need to make sure that you truly understand it. These kids, you missed a half a point. You're just fine, okay? Don't be a point hunter. And then obviously these kids too. Like, look at the upper half of the data set. It's only a spread of 2 points versus this one is a spread of 49 to 42.5. That's 6.5 points. So you can start to see like how we start to make comparisons and decisions about two data sets. And again, remember the whole point of this was to compare last year to this year. Last year and this year, according to my sample, if I'm looking at this, man, we did a lot better this year. A lot better in 2025, at least with the data set I selected. Remember, I selected every fourth. I could do it again and do every third, and maybe the values would be different. But for me, I think whatever changes I made as a teacher this year probably helped. Could have been the group of kids too. There's any number of factors that could go into this, but for last year versus this year, really good. So that's measures of variability. Looking at how the spread in the data set can help us to make comparisons and start to do inferences, which is the next lesson. Good luck.